I'm Brian McQueen. I'm from LinkedIn. Been working there for a couple of years now. Started as an SRE over there and doing dev work now. None of that's very interesting. There's a lot of nerdy stuff, which is pretty cool. So I'm going to get right into the fun stuff. We got a ton of machine learning stuff that happens over at LinkedIn. And it was highly desirable to get all that running in Kubernetes. So the opportunity came up to get Kubernetes clusters going. And of course, we need metrics. We got to figure out what's happening with the cluster. Prometheus is up, and it's a bit of a problem. Prometheus is harder than M3, but I'll get back to that later. So we had to figure out how we're going to store these metrics, and we would really ideally like to store them for long periods of time with various degrees of detail so that we don't have to waste too much disk space. So we ended up looking at a few options. We found somebody was running M3 in the company already, so we gave it a try. So there's a cool feature about M3, which is that it's got this interesting architecture, which is sort of adaptable, sort of components, but you can start off with this slightly bizarre monolithic M3 thing, which even has etcd bundled into it. So you can get that thing going really easily, and you can start seeing that things work. And it's not a big step. It's one nerd party step at a time to start adding more features to the architecture until you expand into something which is professional and exactly what you want. We ended up having M3. We got a cluster of 6 gigantic servers from the machine learning guys with something like terabytes. Each one's got like 40 terabytes of attached disk or something. Giant things. No kidding. And we busted it apart. We moved a coordinator over here and we put a querier over here because these are wise decisions. You want to not have query bombs coming through and knocking out your coordinators and vice versa. Try to separate the concerns from the operational side. That all worked very, very well. And we use the operator. I'll get back to that in a few minutes too. What I wanted to say is that it's Prometheus. Prometheus it's quite hard to make that thing BHA. So aside from I'll just tell you the exact problem. You get a lot of metrics flowing through that thing. It can take you 30 minutes or an hour or whatever to restart that thing. And that puts a hole in your charts for as long as you care to keep these metrics around. You want to scrape everything twice? I don't want to do that. Scrape it twice and then what? Proxy them and thin them out. You know, there's a tool to put it in the middle, a proxy where you can do that. I don't like any of that. We came up with a very super simple solution, which is M3 storing everything long-term and excellently. And Prometheus is storing as little as possible to make that thing do its scraping and emitting. So we can restart that thing anytime you want and nobody even notices it anymore. It comes back up quicker than a gap is going to pop up in the metric stack. So it's a pretty nice solution there. Easy to deploy. You don't need to have multiple Prometheus servers. I wanted to tell you about the coordinators. I'm very impressed with the throughput on those things. They go like crazy. You can have tens of thousands of metrics going through those things in a second, running on fairly small pieces of hardware in a Docker container. Very, very high performance going on with the coordinators. So now I want to get around to what I think is the most important contribution I have to tell the audience. Yeah, I told you some of the generic stuff. And the dashboard is really good. So when you're using the M3, you're going to get metrics. You're going to know what's happening in your cluster. It's really quite nice in that way. So I want to make sure that you folks know that you should be using the operators. When you're putting up this cluster and you're getting this thing going and more than that monolithic implementation, use the operator. It makes it so much easier. And there's a which you're going to be totally puzzled by if you forget about the operators. The topology has to be initialized, or else these nodes would just sit there saying they don't really say much of anything. The operator takes care of that stuff for you. You don't have to run any funny curl commands to make the next step move forward. Told you how Prometheus HA is harder than M3. I insist that's true. So 2 other warnings which are very important. Make sure you are, not only are you monitoring your M3 cluster and alerting on it, you have to be doing the same thing with your operators. I'll give you an example of some problems we have had. The etcd operator stopped working because authorization or access controls changed and it couldn't update pods anymore. Slowly but surely, the etcd cluster that holds all the topology for M3 went down. Lost all your topology, all your metrics. It's going to be awfully hard for you to recover if you can. Similarly, the M3DB clusters operator itself, you've got to be watching these things to make sure they are still able to do the operations they have to do. Or else you're going to be totally blindsided, because you end up staring at M3 all the time thinking, how's it going? Oh, it's going great, but you're not looking at those operators anymore. When they stop working, things can work great for weeks and weeks before you start to see a problem. I think that's about it for the important stuff that I wanted to tell you folks, and that's just about the right time too. So I'll take questions if anybody's got anything. I didn't look at the chat. Chat's empty. Question, the Q&A is empty. I don't feel that it's great to pad an extra 5 minutes of blather. I said what I thought was important for y'all to hear. It's a great tool, high performance, and watch those operators.
Brian, you have one question actually that just popped up.
All right, I will take a look. So I'm going to answer this one live. Question is about throughput. So I'm going to let the guys on the M3 team answer the questions on the limits. I'll tell you that what we're seeing is very easily doing tens of thousands of metrics per second coming through a single small Docker image of a coordinator. Its throughput is very awesome. I've had it going up to close to 100,000 coming through a second. So it goes like mad. You guys, what do you say about throughput?
Yeah, great question. I think like it really does depend on the workload. You know, if you like some of the numbers that that was shared by YY and Nick from Databricks is one set of numbers, and you know, that was like sub 100,000. So below, less than 100,000 per second on the database node side. But as they kind of mentioned, like they have like a relatively high cardinality workload. So the amount of like space and like complexity and cost of every single time series stored there is a little higher, and also just requires a lot of memory, right? And so, and you look at Databricks' numbers, they read back 200,000 per second. So like a lot of the data that they're writing in at 900,000 is being accessed as well with those 200,000 reads. So it's not like you really can like shuffle them out of memory. There's a significant portion that are in memory that need to be read. And if you shuffle them out of memory, then you're just gonna have to pull them into memory every time you query them. So, so like, I guess the memory usage can dramatically like be different between different workloads. Actually, I see Nick is on the call. I don't know if you'd wanna kind of like add any footnotes there, but yeah, I mean, I would say that like, you know, we obviously see multi-hundred thousand per second as well with different workloads, and it's just really up to the. But yeah, Nick, do you have any footnotes to add?
Yeah, well, I just wanted to agree that, you know, we have probably a very skewed heavy write workload, and we have really high cardinality in our labels, and a big part of that comes from having these sort of customer deployments. So we have to keep track of many, many different dimensions in our metrics because we need to be able to pinpoint things. And, we have, tons and tons of customers running tons and tons of different clusters on tons and tons of different nodes. And we need to be able to actually quickly drill down to where problems might be occurring. So our cluster management team really wants all of those labels on their metrics. So yeah, I think it's true. We gave our numbers because I think they're interesting, but I would be surprised if many people had to run at that level. I think you can probably get away with fewer nodes in most workloads as long as you keep your metrics sort of more reasonable. Ours are maybe arguably unreasonable, but we do sort of have reasons for it.
Yeah, I mean, I think one of the philosophies of M3 is I guess, trying to make the most blunt tool in some ways to fit a lot of very different use cases. So there's no wrong way of doing things in some ways by that philosophy. But yeah, that's really thanks for kind of sharing the details on that. And we also have Bert and Misha from Walmart if they want to chime in with anything there.
I don't know how much. I think I caught some of the numbers that Nick was talking about for Databricks, and I think our experience has been fairly similar, tens of thousands samples. So it's pretty good. The coordinator though, we have pushed that thing pretty hard. The throughput you get on that is actually pretty amazing. Occasionally you hit weird issues if you let it go off the deep end, but for the most part it does what it does, and it does it really well. So
awesome. Yeah, I mean, I think over time it would be nice to hone in on a few use cases and perhaps add optimizations around those if folks feel that is something that's obviously for their specific workload, if they're not getting the same kind of performance that we get in our production clusters, which is pushing to at 100,000 or 200,000, then I think it's always great to receive feedback from the community and let us know what you're seeing, and yeah, it'd be great to kind of investigate, get to the bottom of any issues that any one specific workload might be seeing.
All right, I just want to make sure we have enough time for the Walmart folks to give their talk real quick. So if we want to, I see there is one more question in here. Maybe we can answer that while Bert and Misha are talking. But Bert and or Misha, do you want to share your screen or share your slides? Perfect.
all right, yeah. So I'm Bert Harmon. This is Misha Medvedev presenting with me, and we want to talk a little bit about how we're using M3 at Walmart. We'll echo a lot of the themes I think you've been hearing, so happy to go into detail as we can. So why do we choose M3? We have a lot of time series data, thousands of stores, lots of data centers, lots of stuff going on. There was a system in place. It didn't really support Prometheus format metrics, and it was also, we were hitting sort of limits on scaling. And so we were looking for a new sort of time series storage option. The thing that really sold us on this was the simplicity of architecture. So we were talking about scaling there, but the fact that we can sort of horizontally scale and you get a number for your database and it holds whether you're running 3 nodes or 300 nodes. And so that's really something that we liked, right? Because all of our performance tests, we want those numbers to work at large scale. So that the simplicity of the architecture, there's not a lot going on that has to interact with each other is nice. And the fact it's open source and well integrated with the Prometheus ecosystem, sold it pretty well for us. I think Misha is presenting.
Yeah, getting figured out. It's pretty spaced on you, but forward in case. Yeah, so we run across across many clusters. across different geographies and providers. Each cluster ingests millions of samples per second, and it keeps tracks of hundreds of millions of active series, usually. We run active-active between two geographic regions and with 3 replicas inside each. For adding capacity, we found that we usually do 2 different modes. One is scale up existing clusters. This is simple. You add more DB nodes, you add more coordinators query, and then you wait for data to be shuffled around. That might take hours, days. We even had weeks if the cluster is large. Another way we do add capacity is to create a new cluster. This is very fast. If you want a large chunk of capacity added quickly, you stop new cluster, you add it to query, and you start writing. That's the downside. It's complexity. Now you have more clusters to manage. And this is all seamless because of query. Just have one endpoint for users that they can see it seamlessly added.
So yeah, one of the things that is really a learning for us is that our users don't really have a good concept of cardinality. For those of us who are looking into time series databases, it's one of the things we talk about a lot. But the application teams seem to not think about it nearly as much for some reason. So having ways to measure and control that to protect the system is very key for us. The first and easiest thing to do is, enforce limits for Prometheus. It's got a bunch of scrape limit options. It forces a conversation sometimes when you've got people who do need to exceed those limits. But having them there catches the infinite cardinality before it becomes a problem, and can really cut people off when their application starts getting out of control. We also implement allow and deny lists. So we force users to list what metrics they're sending in. This does a few things. One, cuts out the junk. It makes users think about their metrics. It also catches a few cases where we've seen, I want to say it's like Graphite Exporter will put a lot of label data inside metric names. And having, a list of acceptable names forces people to fix their labeling, which is just sort of, much better user experience than having to have these giant metric names. And of course, there's a few cases where you can't cut people off. We do try very hard to enforce these limits as much as possible, but even in the case where we can't, there are just basic system metrics in a lot of cases. Knowing the volume and characteristics of these metrics, so what's our churn of things happening, how much data are we pulling in from where, helps us do a lot of planning. And so it helps us keep an eye on the system as a whole. If we can say, all right, this is what this data looks like, and this is what our regular user data looks like, and this is why these databases perform a little differently.
M3 works best for consistent metrics that don't change a lot. And also the less churn you have, the indexing is more effective. So one knob that we have is controlling volume is frequency of scrapes. So yeah, the more scrapes you have, the more data points you're gonna have coming in, the more volume you're gonna have. The less, obviously, the less, but we noticed a few patterns with different ingest types we have, in general, different clusters. So if you have even the same volume coming in, samples per second, you might see a different performance. So if you have less scrapes, you're gonna see high cardinality or higher active series. And if you have more scrapes, for the same samples per second, you're going to have less active series. And for high churn, you're going to have variation of those. So we have also long-term storage, and that's effectively means we have less scrapes are less frequent, effectively, or we have 600, for example, seconds aggregation. This means our database looks like it's underperforming for the same samples per second coming in. So that's also important to consider.
So stuff we're excited about coming up, both with M3 and sort of in the community at large. Analytic workloads. So we run, all of our monitoring and dashboarding off of the data stored in M3, but now we've got a lot of data in there and people, want to run large queries against it. So we're trying to find better ways to serve those customers for, analysis purposes. That sort of leads into faster and larger queries. The real small use cases of I need to know if my handful of pods work great. When you're pulling, a month's worth of data for like every store or something, it becomes problematic. And so we're always looking for better ways of doing that. We do also use a cache on the query side. So if you're running the same query, we don't cache like recent data, but anything old, we'll try and store those data points just to serve things up. And that helps tremendously for dashboarding. And then ways of doing push metrics. So we're doing a mix of pull and push now. Pull lets us do all of the cardinality controls. Push is much harder, right? So governance around that is something you need to think about for doing push, just so that people don't overwhelm your system and they don't get the feedback in the same way for push. And open telemetry, we're also watching the collector, and that seems to work in a similar like push-pull model of like how does governance work there.
Some of the lessons from running M3 for a while. Scale up early. There's a few ways to figure out when you should scale up. Disk is one, as has been mentioned in previous presentations. Just having some sort of metric that tells you how much you can ingest in general. Bootstrap duration matters. Anything, most of the things can be solved by restarting M3DB nodes, or if you want to adjust the configuration. So tracking also bootstrap time between updates or new versions can help. But there were a lot of improvements recently there. Again, both cardinality and volume matters. Just looking at volumes or samples per second might be deceiving. You might have a huge cardinality while having low samples per second coming in. And the opposite happens. So cardinality usually, or active series, reflects more directly in high memory use. And yeah, set DB side remit limits. It saves us a couple of times. Finding those, what exactly they should be, can probably vary between use cases. Just looking for past performance and setting some things better. And that's it. Can answer some questions.
Thanks. Yeah. I see we have a question about query caching. So yeah, we're using Trickster proxy. I think it came out of Comcast, though I think it's on its own GitHub org at this point. It works pretty well. There have been a few bugs we filed just on like synchronization, and we're trying to get tracing and everything sort of up to par there. But yeah, no, it works well. Yeah, it primarily applies for our dashboarding flows, right? Where we've got teams like, when there's a production issue, there's, a bunch of people loading the same data for like a long period of time, and that data is not changing. So having something in there to just reduce the amount of data that M3 is trying to pull up every time. We saw mostly a performance impact on our query times. Like everything got a little bit faster.
Another question, if we're using aggregator. Yes, we are. We have a 90-day and 500-day namespaces where we using last value aggregation, basically a subsampling. So yes, but it's optional, and so far it's not generally available. Yep. So that's. But we're not using any advanced features yet of aggregators.
All right. Cool. Thanks.
Thank you.
I guess just what last one was like on Trickster. How have you? Is there any elaborate any 2 cents you want to throw in just with like how that project is, like your general like experience with it, and if it's come a long way? I know that it had some like it's obviously a project that's been around for a while and has had like significant set of changes to it. So any commentary would be great to hear.
Sure. Yeah, so a lot of it was built with the Prometheus integration. Like it understands Prometheus APIs pretty straightforwardly. So like the first go round of configuring it is pretty easy. We found that you really need to sort of read and understand the config file. So there's a few sort of non-intuitive things in there. I think it only tries to keep, we set it up kind of weirdly, right? Where the cases we're concerned about are when people try and pull up like a month's worth of data or something, right? And then refresh it every second, right? It's sort of only set up to cache like a few hours worth of data. So we kind of abused the settings a little bit to make that a little bit easier, as well as we wanted to make sure that since there is some processing time, that it wasn't trying to cache the last like couple minutes. We hit a few performance snags just in terms of like there were a few race conditions when we sort of stressed it in strange ways. It's very transparent in the way it works. So you can always throw it in there, see if you like the outcome, and if not, ditch it. And it's catching a double-digit percentage of our queries, so at least on the dashboarding side.
Awesome. Yeah, super interesting. Cool.
I think that was great. Thank you all to all of the speakers, Brian, Bert, and Misha, for presenting. Looks like we actually have one more question. Not sure exactly who this is for. Maybe Bert and Misha. Did you contribute features into M3?
We haven't contributed any code at this point. But we have been active on issues and in the Slack.
Yeah, I'd say there's several features that were basically designed. Yeah, I mean, came out of like operational things that you folks ran into, right? As far as I can tell, I mean, I think like the majority of the community, like the work that's gone into open source M3 is folks run into issues. We've like worked together to fully understand them and then move forward to make, again, that kind of like that really blunt tool that works across a large, significant set of use cases. So I definitely say that like some of the most beneficial open source contributions has been stuff of that nature, which is I think really interesting.
I got a comment about this. This is common. This section is contributor oriented. So I have a contributor comment. I made some changes for the M3DB operator. I found that working with the guys and getting those things in was nice and no problem, and the code's good. It was easy to understand. So don't be afraid of facing the tiger and grabbing some work and trying to get it done. There's tickets and I'm sure there's more features that the guys would like to see in place. They don't even know they need them yet.
Yeah, we would be delighted for folks to chime in and that yeah, I know that so the M3CTL command line tool super useful especially for like being able to source control some like operations that you want to perform and stuff like there's definitely been contributions that we've had from kind of all over the place. I think like if we set up if we set up some more time to regularly get together with folks who have dedicated time to be able to spend on this, like then we can get more into a groove of like actually coordinating this stuff. Most of the time it's like, as we were saying before, like face an issue, get stuck in, and kind of like work directly one-on-one with folks in the community. Awesome.
Yeah. Yeah. Thanks again to all the speakers. I think we're gonna jump into a quick 15-minute break, and then we will be back for the last session of the day, which is gonna be a fireside chat and Q&A with Martin, Rob, and Matt. So we'll just go ahead and take the break real quick, and we'll see everyone back in about 15 minutes.